Hello, in this video we're going to be talking about exergonic reactions. So let's not waste any of your time, let's get right to it. Now when we're talking exergonic reactions, one of the things you want to say one of the things we want to say first is that this is a just like the previous two, just kind of a one slide video, but there is a ton of information on here. So you may be thinking, okay, notes wise, what do I need to do? Obviously you want to get to two lines down at the very bottom, but you certainly also want to collect all of the information in the graph and the figures and graphs beside me here as well. Those are all loaded with multiple choice questions, potentials right there, so be sure you capture all of that. Now when we're talking exergonic reactions, if you look at the graph, the part of the graph to the far left, that's where it begins. Obviously you're familiar with graphs and you understand how graphs work, but you have the idea the reaction occurs there at the top, and when it's done, the reaction is done, you can see the energy level is down almost to zero, which means it released a bunch of energy. So exergonic reactions release energy. So right away, if we think about our words, if we know we're going to release energy, then we know we're breaking apart a molecule. And if we're breaking apart a molecule based on our words that we've familiarized ourselves with, we know that hydrolysis is the process that occurs. We know that energy is released, so we got kinetic energy. We know that it's a catabolic pathway. The enzyme that was a part of this process, and when we get to enzymes, we're going to take both the inorganic and exergonic graphs and add enzymes portion to that. We're also introduced the idea of activation energy and things like that. But by understanding that we're breaking apart a molecule here, it gives us words that we can use to help explain what's going on, as we mentioned in the previous two videos. We're releasing that free energy. So since we have less energy at the end than what we started with, you can see on that graph the y-axis is energy amounts. You can see that I don't have any numbers, but you can see that the graph starts at approximately 60% from the top to the bottom. So whatever energy unit it is, it had a bunch, but when the reaction ends, we can see that it's almost zero. So that's why it's considered negative G, or negative energy, because we have less than what we started with. Okay, we lost some. The word spontaneous that you can see there, what that refers to is that exergonic reactions can happen spontaneously in nature, and it could simply be just the energy from the sun. It could be just two elements that react when they come in contact with each other. It could be whatever the situation is, these can happen spontaneously, or you don't have to add any additional energy because it already has energy. Okay, it has it, so therefore it can happen spontaneously or naturally. When we get to endergonic, we'll see that that's the opposite. Those do not happen naturally. Something has to physically put things together. Okay, and this brings in the idea of entropy that we'll talk about when we talk about the laws of thermodynamics. If you think about your room, it can kind of get messy just naturally, just as you go through your week, whether it's clothes or books, just kind of naturally it can get messy without any real effort or thought process. But to clean your room, sometimes that takes a lot of work. I know growing up, I know with Patrick growing up, and hopefully he never sees this video to know that I'm sharing this story, but when it became laundry day, we could jokingly, and we did this plenty of times, we could go back through and determine what clothes he wore on individual days, because he had a habit of taking clothes off and then just laying them on this chair that was beside his bed. And so you could go back through, Fridays to be on top, and then Thursdays to be underneath that, and then Wednesdays to be underneath that. So he wasn't good about putting things in the hamper, which was also right beside his bed. But that's a story for another time. But it's just the idea of exergonic reactions can happen spontaneously because it already has the energy within the molecule to perform the reaction. The idea of catabolic pathways. And again, we can't emphasize it enough that these words go hand in hand, and they just work together and to explain everything that is happening. And this is something we'll do in class quite a bit as we talk about these things. Knowing if you're building or breaking a molecule gives you the tools to use to discuss and to describe what's happening. But it's just the idea of these reactions, as I mentioned before, we'll mention a bunch of other times, these things go hand in hand. They aren't one or the other. Okay, they're going on at the same time. If you are building a molecule, then you are breaking down another molecule, and each set of words get used at the same time to reach the same goal. And the idea of energy being released in an exergonic reaction, catabolic pathways, that energy is used to build the other molecule. Endergonic reaction, anabolic pathways. So again, especially when we start looking at diagrams in chapter 7 and chapter 8, you'll see this process happening over and over again of simultaneous building and breaking, and all the words associated with it come into play. Well, that's our video over exergonic reactions. When we come back next time, we'll be talking about endergonic reactions. We'll see you then.